Hello and welcome back to AU Lab. Andrew Karpathy's AutoResearch Project is everywhere today. The idea is very simple but powerful that lets an AI agent run its own research loop, which including propose or experiment, run it, evaluate it, keep or discard, and repeat. No human in the loop, and actually the entire workflow is happening when humans are on bed overnight. The agent does science totally by themselves. I read through the repository and the core pattern clicked immediately to me about this idea of auto research. It's not just for training neural nets. Even the project itself is used to implementation of a nano chat, but actually the loop works for anything with turnable parameters and a measurable score. So I took the idea and built something practical with it. That is an autonomous RAG pipeline optimizer. It ran dozens to hundreds experiments overnight for very few cost of the token by using cheap models, and doubled its own quality score at the end for a better RAG pipeline implementation. So let's have a quick overview of how AutoResearch works. So for the project structure, the Human Rights Program MD, that is the agent's research methodology. Point your agent here and let it go. Okay, the file is edited and iterated only by human. And the agent will write train.py for the actual experiment. Each experiment is a git commit. If results improved, it will keep it. If not, git will reset and try again. The only thing to do is to try to change the architecture, the hyperparameters, the optimizer, batch size, and so on. It has a fixed 5 minutes time budget, makes every experimental directly comparable. So the entire core loop is still simple and straightforward that propose, run, evaluate, keep or discard, and repeat. So the key insight I took away is a pattern that's not just limited to training the models and neural nets. Any system with turnable parameters and a measurable metric can use the same methodology. So that I applied it to a RAG pipeline optimization. So this is the project Auto RAG Optimizer that I created to leverage the auto research idea, seeing how this idea can help to improve the RAG pipeline overnight without human in the loop. So here I'm in the project folder and only one command to start this workflow. So I run Python 3 run experiments.py and add auto or automated running for 10 times iteration. I have to go into the virtual environment and run the experiments again. Okay, now you can see the auto RAG optimizer is starting for max runs of 10. And the system starts a baseline experiment right now with the model that listed in the open router, including the embedding model Q13 embedding 8B and the LLM model Q1 3.5 flash model, and with other parameters like the trunk size, trunk overlap, top K, temperature, search type, splitter, and so on. So the system will score it using an LLM as a judge methodology, then ask a research LLM to propose the next configuration. So each cycle will including building the pipeline, running queries. Here you see that load 20 test questions from the test query JSON file that I preloaded at the beginning. The system will use them to do the evaluation query to the RAG system to see the result. And after that, it will propose the next running of this cycle. So you can see here is still using the query embedding and query chat through these 20 test questions to the current configuration. And also I have the document pre-saved, let the system to optimize its performance towards this full medical document. So here you can see it start the evaluating for 20 QA pairs that generated on before. Now it's doing the evaluating of these pairs. So while it's running, we can go back to see my previous experiment result from the file researchlog.md. So when you look at the table, each line including one experiment. So the first line is the baseline experiment that I run at first. So you can see the status marked as baseline, and the average score is 0.365, which is quite low with the free NVIDIA model and the Q1 embedding model. So after that, there are 20 experiments happening. The second experiment that using the Q1 3.5 flash model and with different trunk overlap and trunk size and top K that moved the score to 0.6, and this result has been kept because it's higher than before. And you will see the next text that simply changed the trunk overlap and top K has been discarded because the score is lower. And after learning that, let's see how to create this project. So today we don't have to build by ourselves. The AI code agent can always do this for us. So I open this Windsurf IDE and give it one prompt, and also put the original AutoResearch repository in the working folder. And I wrote to the model to say, create a complete production ready Python project titled AutoRag Optimizer. This project is designed to run autonomously on a server to find the optimal RAG configuration through iterative experimentation. So the core idea is inspired by Karpathy's AutoResearch Project to let the agent to refer to the original project and to understand the loop and simulate the structure to this project. So here I ask the code agent to build the orchestrator Python code to be the core engine, which must read the research log MD is what we saw before, including all the past experiments, and call an LLM as the researcher with a system prompt that tells it to analyze previous scores and suggest a new config JSON. So every time the parameters were including in this JSON file, and also update the JSON file and trigger the RAG pipelines. And the RAG pipeline Python is a modular script that loads parameters from the config JSON using LangChain and files to index a local folder, including the documentation that we preload into it, and also track the token usage and estimate the cost per experimental. So I don't want to spend too much time on this experimental demo. If you use commercial models overnight, you should take care of the usage and the cost. And evaluator.py file is a script that uses RAG-as library or fallback to a custom LLM as a judge methodology to score the RAG answers. So this is very important that every time the scores is generated from here for each experiment. So the scores including calculates the faithfulness and answer relevance and save the final scores to the scores.json here. And the config JSON, which we have already covered. The research log is also covered, that a markdown table to log the past results of experiment. And the visualizer py is to generate charts for the results report. So I will show you this later. And also use the OpenRouter LLM cores, which is very straightforward API that instead of using high-end commercial model. And my goal is to have a final code with plug and play, and I want to put my PDF documents in a folder. I will provide my API keys of Open Router and let this run overnight to find the perfect rack settings. So if you don't know the Open Router, here is this platform. So you can search for the models that you would like to test with the cost from totally free to the equivalent price of the commercial models. After this project generated by AI coding agent, you should make sure you have manually done two things for this project running successfully. The first one is you have to preload the documents that you want to ask question into for the rack. Because your final result of the combination of the parameters is depend on what kind of documents and what the scale of the documents you put into your system. So here I put 4 medical documents for this demo. The second thing is that you should fill into the test questions.json file to preload at least 20 question and ground truth pairs into it to make sure your evaluation agent knows what the correct answer to compare with. You can use the high-end commercial model to read through these documents to generate the questions and checked by you manually to make sure the high confidence. That's very important for the final scores that evaluate by the research agent. To look into the detail, in this one loop, the orchestrator is the brain of the system. It calls RAG pipeline to answer questions that we preload, sends results to the evaluator for scoring, and logs everything to a markdown table into the research log MD, and then ask an LLM researcher to propose the next experiment with a new configuration come back. The researcher sees the full history and the parameter bounds to generate the visual charts. That's the entire science research of the RAG pipeline optimization. Now let's check the charts that automatically generates from my previous experiments. It has a dashboard HTML5 with several charts images. So if I open this in my browser, you can see that the dashboard including total experiments 20, captive improvements for 5 times, and the baseline score is 0.36. The best score is 0.75, and total improvement is 0.38. So from the first chart, you will see the score progression. The green line tells the story that the baseline starting from lower than 0.4 with the free NVIDIA model, if you remember, and the experiment 1 jumps to 0.6, and the system figure out that a better LLM matters most. Then a plateau from the experiments 3, 2 to 6, that's indicating the system is searching, typing different overlap size, temperature values, score thresholds, and most get discarded with this gray dot. Then the experiments 17 and 18 is the breakthrough. The system tries the character splitter instead of recursive, and the answer relevance jumps from 0.4 to 0.6, which contributes the best scores to the 0.75. And the metrics here tells the 2 stories. The faithfulness was higher early to 0.85 to almost 1.0 across most experiments. And the system was already good at grounding answers in context at that moment, but the answer's relevance was the bottleneck, stuck around 0.35 to 0.4 for 16 experiments. And the character splitter unlocked it to jump to 0.6. So the system identified the real constraint without being told. And the parameter impact that the including the trunk size in different scores, top K, and the temperature, and look at the categorical impact. The character splitter produces dramatically higher scores than recursive here by clearly showing the chart. That's the kind of insight that takes human hours and manual experimentations. And this is the experiment outcomes that record 70% discard and 20% keep. So from this AutoResearch idea leveraging experiments, you will see clearly that the AutoResearch loop generates beyond training. That means any system with turnable parameters and measurable metrics can be automatically optimized. So you only have to define the parameters that will potentially impact the performance of the system, and you should also define the metrics that can measure the performance. And the methodology of evaluation is also very important to do this kind of experiments. And 3, you will see that by using LLM to do this AutoResearch, when the LLM researcher exhausted some numeric parameters space first, in this case it's the splitter method, then it will make categorical changes that produce the biggest improvement. Like here, it starts using recursive splitter and then change to the character splitter after its use of all the potential numerical parameters for the recursive splitter method. And it's the biggest advantage that using LLM as a researcher. That's all for today. If you want to try by yourself of this project, you can find the source code in my GitHub repository. And if you have further questions or ideas, please drop them in the comments below. Thanks for watching. I will see you in the next video.